because it is the most important exercise, the most confusing. Afterwards, it's going to be easy. But the theory behind it is what I want you to take. And it's a very easy theory. It's a very easy concept. It just looks difficult. Looks is the key word. So as I'm presenting this to you, I don't want you to keep thinking of the symbols. I want you to think of what you've learned in Year 9. Everything you learned in Year 9 is going to be applied in your calculus. Next year, 2/3 of the course is on Year 9 stuff. Literally. I'm not joking. Well, whatever the next class is doing, if you ask them, they're currently on tangents and normals, and that is all straight line stuff. It's Year 9 mathematics. Y equals mx plus c is what you're doing. So if you understand the theory I'm trying to talk about today, you've covered a lot of what you need to know from calculus. Okay? It's a very simple idea. I promise you, I say the same things to my Year 12, and I repeat the same words over and over and over. Okay, same words over and over and over. So you're just going to drill this in. It's a straight line. Okay, everything's to do with a straight line. So here we go. First principles. You have to learn, when we're talking about calculus, when we're talking about calculus, we're actually talking about it all comes from this rule. And this rule actually you've learned in Year 9. We're just using what we've learned in Year 9 to generalize it. Okay, so this is the idea. If I gave you this curve, okay, it's a cubic curve. This is the curve. Now, the curve is made of infinite amount of points. Think about it. This is a point, that's a point, that's a point. There are infinitely many points on the curve. That's the key step you have to understand, that there are infinitely many points or coordinates on the curve. Okay? Now, for every curve, you can draw what we call a tangent. Okay, a tangent means that you're going to draw a straight line that just skims the surface. That's what it means. If you can draw a straight line that skims the surface and it only touches one point, it only touches one coordinate. Okay, so for this particular point, I would have to draw a straight line on the outside where it touches once. That's the tangent. That's a tangent line, but that's one line. For another point, I would have to draw another tangent line to get the straight point. To get this point, I have to draw another tangent line that touches that point once. So a tangent line will touch a curve at only one point. That's all you have to understand. Now the cool thing is, all you're doing the entire chapter of calculus is analyzing the tangent line. And the reason why I said it's related back to Year 9, because if you know everything about Year 9 straight lines, y equals mx plus c, you've learned pretty much the course for it. That's how easy it is. Okay? I can tell you this right now. I can actually form parts of what you already know, and I'll show you how it moves all the way to where the others are right now. Okay, I'll show you. Remember back in Year 9, you learned straight line equation, right? And it was y equals to mx plus c. What was m representing again? The gradient. What was the definition of gradient again? Rise over run. Very good. How do you find, what was the rule to find rise over run again? Anyone remember, how do you find, if I gave you 2 points, what do you do again to find rise over run? How do you do that? Very good. This y2 minus y1 over x2 minus x1 is the rule that we're learning today. We called it back then just y2 minus y1, x2 minus x1. It's rise over run. No different. We just give it a special name now. We call it first principles. And I'm going to go back to that later, okay? But now, let's talk about the gradient a bit more, because everything we're going to do is to do a tangent line, right? We said a tangent line is a line that touches a point once. And we know that a straight line has to have a gradient, and that's all you're really doing. All of calculus, everything you're doing is just to find this. C has always been easy, because what was C again? The up or down, or the y coordinate, the y-intercept. And how do you find the y-intercept? Very easy. Let x equal to 0. So that was never a problem. Finding the y-intercept has never been a problem. What are you actually doing all of calculus in 2/3 of next year's course is gradient. That's how simple it is. And in my Year 12, all I ever say to them is just remember calculus, everything what you're doing is about the gradient. So let's think about the gradients. What have we learned about gradient? We said rise and run, y2 minus y1, x2 over x2 minus x1. But also, how many types of gradients do we have again? We have 4. What were the 4 again? We have positive, negative, undefined, 0, and undefined. Fine. Now remember when you learn tangents in tan graphs, that's what I was talking about too. I talked about that there are 4 different straight lines you can have. You have a positive, you have a negative, you have a 0, you have an undefined. So I'm going to write underneath. Now, you're literally going to use gradient rise over run. You're literally going to analyze the gradient type in most of your courses right now. Part of your course, that's really all you're doing. See, I can even ask you this question right now. If I were to draw a tangent line, so at this point here, if I had to draw a tangent line to touch that point, what's the gradient of this tangent line right now? What would you say? Positive. And that is part of the next year's course. You're going to learn how to sketch what we call tangent graphs, or like gradient graphs. And you just figured out at this point, at x equals whatever, this is positive. Where is it negative then? Where would it be negative? Just looking at this, where would it be negative based on the x-axis? Where would it be negative? But between where? See, I didn't even have to, guys, thank you. I didn't even have to go through the entire course. You just picked up what I just told you. I just asked you when is the graph negative, and you were able to tell me it was between B and A. If you choose any points here and you drew a tangent, it has a negative gradient. This line here has a negative gradient. This line here has a negative gradient. This here has a negative gradient. Everywhere here, and I'll show you what in year 12, how the question would have been designed. Instead of me saying, where is it negative? You know what they would do? They'll do this. Whoops. They'll say, question A, find when f dash of x is less than 0. Whoops. And that essentially means, to say, sorry, that's f dash less than 0. Let me do it again. F dash, and a lot of students don't know this. When I put it into the year 12 SACLA exam, students look at this and go, no, I have no idea how to answer it. But when I just asked you just now, without even teaching you anything about first principles yet, you were able to answer that question. You said it was B to A. And that's essentially what the year 12s are doing. I'll give them a graph, I'll give them a function, and then I'll say, find when f dash of x equals 0 or less than 0, and equal to 0 or greater than 0. All I'm asking is, when is the gradient negative? When is the gradient equal to 0? When is the gradient positive? If you keep in mind that calculus is all about gradients, you've got the course. That's how easy it is. But if you start looking at it as symbols, you're going to look at that and go, I have no idea what it's asking. Okay, so I'm just going to try to reiterate that idea. The symbols, try to understand the set notation, try to understand what they're asking. Because if you understand it, it's a very easy theory. Because you've done this before. Okay? Now, if I asked you, the next question is what the others are doing right now when they're on tangents and normals. If I ask you this question now, where on this graph would you predict, or where would it have to be, where the gradient is 0? Gradient of this tangent line. When would this tangent line, when am I going to draw a line where it's going to be
B or A?
Thank you. Right here. See, we said this was positive. Positive, positive, and you can see the line has to eventually start flattening out, and the only time it's going to be 0 is at the maximum, or the minimum, because right here, after the 0, it becomes negative. After negative, 0. 0 back to positive. So you know what those points are called? They just give it a name. When I asked you just now, I didn't use anything but year 9 knowledge. All they ask you, they tell you that they call that stationary points. And that's what the others are learning right now. They've done an extra about a week and a half worth of work. But really, the theory that you need to understand is just gradients. And if you try to look at a curve and understand it as gradients of a tangent line, that's as simple as it is. Where is it going to be 0? Clearly, at a maximum, when you change, like where the change is from positive gradient to negative gradient, there has to be a 0 somewhere. And that 0 is where the maximum point is, or the minimum point is. Okay? We'll talk more about that later on, about types of, types of points where gradient is 0. But we give it a special name, we call it stationary points. Okay? But for today's lesson, we're going to focus on one part of the year 9 maths. So we're not going to talk about this gradient stuff here. We're going to talk about how do you find the gradient. Okay? And that's the key. That's what calculus is, and that's what first principles is. We're going to focus on this y2 minus y1 over x2 minus x1. And then I'm going to tie it in so that you just get a feel of what you're actually doing, because all the other rules you can memorize. I'm going to show you the rules in the next few lessons. You can memorize, we can do 2 sessions, two exercises in one. It won't take long, because if you memorize a rule, then you apply the rule. But there's no point in applying the rule if you don't know what you're finding. At the end of the day, you're only finding the gradient. That's how simple it is. You're just finding the gradient. So if you get your head around that, that's all you need to do. Okay, so today's lesson, we're going to focus on y2 minus y1 over x2 minus x1. So here we go. I'm just going to go past all this. That was just the theory of what I was trying to describe before. Now, first principles. Let's start with where the rule comes from, because remember, it's the notation that scares you. You had no problems with y2 minus y1 and x2 minus x1, right? Still keep that in mind. It's the same thing. Okay. Now, remember with finding gradients, if I asked you the theory, I would say, how many points do you need to make a straight line? How many points do you need? 2. You can't do it with 1. True? So, when we said tangent line, the problem with tangent line is it touches the curve at 1 point. So if it only touches at 1 point, how is it possible to find the gradient at 1 point? Because we said we need 2 points. So this is where the theory comes in, and then you'll appreciate why it works, or what the theory is, okay? So you told me that you need 2 points to find a gradient. But what I really want is I want the gradient at 1 point. So hypothetically, let's say I want the gradient at, wait, did I draw the gradient line? Did I draw it? No, I didn't draw it. Okay. Let's say I want the gradient, which is a straight line. What if I want, oh my God, why does it keep doing that? Okay, here we go. I'm just gonna rub that off. It's too old. I need to get a new one.
Oh, the new one's just as bad.
Oh yeah? Okay, now I've drawn it as best as I can on that screen. But what if I wanted to draw a straight line and imagine it only crosses or touches that surface at point P once? This is what I want. This is my straight line. And there's a y equals mx plus c. All I want, so I want to know what the gradient of that line is. Because I just want to know m at this point. At that very point, I want to know m. Because there's a lot of m's. There's this m, there's that gradient, there's that gradient, there's a gradient at q. But I just want to know the gradient using 1 point. Now you told me that we can't find the gradient of 1 point. We can only find the gradient if I have 2 points. So this is where the theory comes in. If I got point P and point Q, okay, then here's the question. If I found the line, if I actually drew a line to cross between Q and P, that's a bad straight line, but it'll look something like this, okay? That's my straight line between point P and Q. That's a very different gradient to the green. Green is what I want. Now, this is what the theory is saying. They're saying, all right, well, what if I move point Q a bit closer to P? See, on the curve, there are infinitely many points. I don't have to pick that point Q. I could pick maybe this point. Now, what if I picked it halfway between P and Q? Let's say here. If I did that, okay, if I pick that, I'm going to do another color. I'm going to do purple. Let's say point Q was here now instead. Then I would draw between point P and point Q. If I had to connect that, can you see, I know it's getting a bit messier, but can you see between P and Q versus P and Q over here, which one is closer to getting to the green line? The first Q or the second Q? The first one being this one, and this is the second one. So here's the logic. Logic is, what if you can move Q infinitely close to P, but not, that's what you just said, fantastic, because that's the theory. The theory is just saying, well, if you move a Q closer, it makes sense that the gradient will get closer to green, which is what we want. We want the green gradient, not the blue, not the purple. And the only way to reduce that is if you make the distance between P and Q shorter. And so they're saying, what if you chose, let's say P was at x equals 1. So if this was x equals 1 here. Then what if you chose 1.0000001? That's really close to 1. Surely if you find that gradient there, it's very close to the actual gradient. Infinitely so small that it actually is different 2 points, but they should have a very similar gradient. That's the theory. Does that make sense? Yeah? Now, if that theory that I just said makes sense, that if you pull Q closer to P so that you have 2 points and you can make a gradient out of it, then if the theory is if I made it infinitely small, I should technically have the same gradient. Okay? So, if that is the theory, then how do you find the gradient again? You told me, and I'm going to rub all this off, you told me that it's, to find gradient, it's y2 minus y1 over x2 minus x1. That's what you told me. So if I said that at point P, I have x, so this is my first x coordinate. If my curve, which is a quadratic curve, is x squared, if this was x, that would be x squared. True? So if this was 3, if I sub 3 into the equation, 3 squared would give you 9. So if I give you x, then this point here, the y coordinate has to be x squared. True? Now, if I have x, that point there has to then relate to x squared. Now let's say q. Now how do I define q? I said I would just want to pick another arbitrary point, right? So this is how they do it. They say, what if I said q is h amount away from x? So let's say an extra h. So then you would say, yes, x plus h. X plus h would tell me that this x coordinate here is now x plus h. What is h? H is the amount that you're moving away. So I can move 1 unit away, I can move half a unit away, I can move 0.01 of a decimal away from x. So that will change where q should be. So if I said q is now at x plus h, how do I find the y value? If you know it's at x plus h, to find the y value, you would square it. Yeah, that's it, because this is what the function says. So whatever x is, square it, and you'll find the y value. So that's what I did here. So watch this. If I put it in, what I'm going to get is these are my two coordinates. When it's x, then it's x squared for the y value. When it's x plus h, actually that should be x plus h there, sorry. That should be x plus h, and the other one should be x plus h, square it, which is what Seb said. And it's true. Now, you've got 2 points. How do you find the gradient again? You would say y2, or this is y2 minus y1, x2 minus x1. So let's write that down. I'm going to write exactly what we just said. I'm going to label it. I'm going to color it in.
Binomially expand.
Very good. And that's what this exercise is about. It's a long, tedious way, but the theory is correct. Okay, so here we go. This is y2. This is x2. This is y1. x1. Let's put them all together. y2 was x plus h squared minus y1, which we had x squared, divided by now x2, we had x plus h, minus our original x value, which was x. Now this is the special thing. X minus x is going to cancel out. They're going to cancel, and they will always cancel out. Listening? X minus x will cancel out. And so what do you end up with? In this case here, you will end up, if you expand the numerator here, expand x plus h squared, you get x squared plus 2h plus h squared minus x squared divided by h. If I skip too many steps there.
2hx.
Oh, sorry, you're right. 2hx. Thank you.
0.
Thank you. All right, now 2hx. Now, up to this step here, all I did was I expanded x squared, 2 times h times x, and then square h, and that's minus x squared. Now you notice that the x squared and the x squared here are going to cancel out. X squared minus x squared cancels out. And have a look at this. This is where it's cool.
Oh, you can take out a h and then you can cancel them out.
Very good. This is really good. Now we're getting somewhere. Now, exactly what Seb just said, there's a factor of h in all of them. You can take out the factor of h by factorizing it out and then cancel it out. So I'll show you. This has a factor of h, so if I take out h, I get 2x plus h all over h, but h divided by h is 1, so I end up with 2x plus h. Now here's my question. What were we doing? Don't lose track of what we were doing, okay? Because this is what happens in my year 12s. We forget. I was going through all these techniques, we forget what our purpose was. What was our purpose again? We're trying to find the gradient at P. At P, I just wanted to know the gradient of this line at P, okay? Now, what was the theory again? We said that what if I made h distance away, right? But what was the goal? What if I made h very small? What if the distance was infinitely small. They're not exactly the same points, but what if they were just slightly off? So if I made h really, 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 really small, then what does 2x plus a very, 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 very small number equal to? 2x. Very good. 2x plus something very, very small has to be very close to 2x. So, and this whole thing, how do you say that in mathematics? This is what we write. We write this in mathematics. We say limit. This is the notation you have to learn. This is what I'm saying. In year 12, students get sort of bummed out by all the notation here, but really all you're doing is y2 minus y1, x2 minus x1. And here, all I'm trying to say is, listening, what if the distance between h, which is how much you move away from x, what if I made that very small? Because that's what we wanted. We wanted to pull q as close as possible to get the gradient at p. What if that was really small? This is what the line means. Okay? What if h is very small? Now, if h is very small, you just told me that the answer will approach 2x because h is so small. Another way of thinking about it is like, imagine if I actually sub-zero it. If I sub-zero 2x plus 0 is 2x. Okay, that's essentially what you're saying. Now, here's my questions. What's a 2x mean? It is? What's 2x? What is 2x? So don't forget. Thank you. So don't forget the purpose. Don't forget what you've been trying to do. At the end of the day, I'm going to teach you all these new rules. Trent, will we talk next time? Thank you. At the end of the day, what I'm trying to describe to you, all these rules I'm going to teach you in the next few lessons, you're going to memorize. You're going to get good at it too, because it's just memorizing and applying. You're going to memorize these rules and you're going to do really well. But the reason why in year 12 and it's 2/3 of the course is because we forget what that answer means. And you just told me, remember, we were trying to find m. This whole thing just describes the gradient. So when you write m equals to 2x, now I'm going to bold this here. What does that mean? Remember, I didn't know what x was. What is x? X is here. X is the point of p. So if x was 1, if this was at 1, okay, then that point there would be 1 and 1. At 1, 1, if I wanted to know the gradient of a tangent line, if I drew a tangent line, then here would tell me, they would say that twice whatever x is, that tells you the gradient. So what I'm trying to say is, if you want to know the gradient at, let's say, at x equals -1, so if I got this point here and I got a gradient that comes down, let's say I want to know the gradient of this straight line. So y equals mx plus I want to know the gradient at that point. Then all you have to do is sub in -1 into this formula that just figured out. 2 times -1 tells me this gradient has to be -2. At that point, this line is y equals -2x, and I don't know what c is. That's all it means. And that's what you're doing in year 11 and 12. You're just working out the gradient. We call this the gradient function, because it tells you a rule for every point on the curve. It doesn't matter which curve you want. So if you want it at 2, you want to know the gradient at 2. What is the tangent line, the gradient of the tangent line at 2? We've got the rule now. Now we know the rule. Sub 2 in. 2 times 2 tells me the gradient at 2 has to be 4. That's what we know. Okay, so remember all this. What were you doing? You were trying to find the gradient. We found the gradient. We just didn't know what x was. We don't know which point on the curve we want to find. But if I told you which point, I said at x equals 1, find the gradient at that point on the curve. Okay, so if I drew another random graph, if I drew, let's say this graph here. If I drew some random graph like this, just like that, okay? Make up some graph, right? If I drew at x equals 5, and I find the point on the curve, this point, that point will have a tangent line. It has to draw a tangent line. So if I draw a tangent line, that one has y equals mx plus c. I just want to know what the gradient of that line is. So how do you do that? Find the derivative or the first principles. That will tell you how to find m. And then sub in 5. That's essentially what it is. So I just gave you a curve. I gave you x squared, y equals x squared. We used first principles, and we just calculated that the derivative, which we use f dash of x, is equal to 2x. Well, I'll use another notation so you don't get confused. We found the gradient was 2x, and all it just means is, if I want to know a gradient at 5, at x equals 5, this is the point. How do I draw a tangent line? A tangent line is just a line that touches that point once, and it's called y equals mx plus c. I just want to know what the gradient is. But I figured out the rule. That's what you did. You did this whole thing here to find out the rule. And the rule says twice x. Now, if x is 5, which is at that point, x is 5, then the gradient must be 10. And it's only 10 for this graph here. So this particular straight line describes that point. So at x equals 5, the gradient of that line is 10x. I still don't know what the y-intercept is. And that's what the others are doing right now. When they're doing tangents and normals, they're only one little concept ahead of you, where they're just finding out c. Now, if you really think about it, how would you find c? Back in year 9, how would you have to find c? If you know the gradient, how do you find c? What do you need? Yeah, you need to solve an x and y coordinate, but you already got x. You know x is 5. So how do you find y? How do you find y? If you know this is a quadratic graph, x squared, and you know x is 5, how do you find y? How do you find y? Square it, because I literally said it here. I said y will equal to x squared. So if I told you x is 5, then what's the y coordinate? I'm just asking what's y? 25. 25. So if y is 25, you can actually answer this question right now. This is what they're doing right now. They're like exercise 18 or whatever, but they're just doing this. All they're doing is you just found out this is 10. To find out c, if that's 5, then y is 25. Sub it in. You got y equals 10x plus c, sub 5 in, so 10 times 5 plus c equals 25, 50 plus c equals 25, so c must equal to negative 25. So what is the gradient? What's the equation of the tangent line at x equals 5? I already know. It's y equals 10x minus 25. Bam, that's what they're doing right now. So those students that you're talking to, they're saying they're at tangents and normals, they're only little, like in terms of progression, they're only ahead of you by a little concept. That's what I'm saying. The theory is really expandable. But it's very easy. Why? Yeah, it's very easy. It's like it might go multiple sort of areas, but really it all comes back down to gradient. The more you understand that it's just a gradient, you are set. This is all year 9 stuff. Everything I've just done with you right now is year 9 mathematics. Okay? So, the only thing that you needed to learn was this. Now this looks scary, I understand. The notation looks scary, but it isn't. You're just doing y2 minus y1, x2 minus x1. That's it. That's how simple it is. Okay? Let's do another example and then I'll leave you with 17A. Okay, 17A. So, here we go, let's do another example. Alright. Let's do this one. So,
Very expandable.
okay. Last example. Here we go. So I'm just trying to teach you all the theory. So remember, it's all about gradients. Okay, so if you look at this function, it says f of x equals to x cubed. So you got f of x equals to x cubed. Okay? Now you can draw x cubed if you want, just to visualize it. I'm going to draw on the side so you can see. This is your cubic graph, just in case you forgot what a cubic graph looks like. Okay? Now, what's the question? They tell you, they want you to find the gradient of the second root 2, 8. So when x is 2, y is 8. There's that point P and point Q. Okay? Now to find the gradient of the tangent to the curve at the point 2, 8. Now, there are two parts to this. They said they want you to find the gradient between P and Q. I'm going to draw here. Gradient of P and Q. It looks hard, but it isn't. Remember, it was y2 minus y1. If you want to know the gradient, I'm going to do it in another color. If you want to know the gradient of PQ, you told me it is y2 minus y1 divided by x2 minus x1. Yeah? Now, if you think about it, this is your x1, y2. This is your x2, y2. So x1, y1. If I had to apply exactly what you've been doing, then apparently y2 is 2 plus h cubed minus 8, which is y1, divided by x2, which is 2 plus h, minus 2. That's pretty much what I did before. The only difference is what I did before, I was using x rather than a number. Because right now you've got 2, when x is 2, y is 8. That's what we know. At this point, that's 2, 8. That's what we know. Okay? Now, if you were to simplify this, 2 cancels out with the 2. You got 2 plus h cubed minus 8. Oh my god, I hate this pen. Why does it do this?
We should get you a new pen for being such a teacher. Change the new pen.
Oh, there it goes again. I don't know why it keeps doing it. So, 8. There we go.
So that pen is fast.
Alright. Now, up to this step. This thing. Now, up to this step, this is your first principles. It's y2 minus y1 over x2 minus x1, right? The only part that would have been tricky is simplifying it. Now, if you're having troubles with that, you still need to learn the skill. But in terms of doing the exercise, you can expand that on your calculator if you want. Okay, you got to know how to expand cubics as well. That is the expectation with year 12 that you can expand quadratics and you can expand cubics, right? But now you're going to have to expand this and simplify the top. But that's not my interest. You see, what my interest is that you understand the theory. The theory was y2 minus y1, x2 minus x1. And what was the theory? H, which is the distance away from 2, if I reduced it to 0. The reason why you have to simplify is because if you made this 0, what happens? What happens if the denominator is 0? Nothing. Undefined. That's why you have to simplify. So every time you expand and simplify, you'll find that the h will cancel out. That's why you have to do it. Okay? That's the reason why you have to simplify. Otherwise, that becomes a problem. Okay? So all of your exercises right now, you're going to find that you can remove the h. Okay?
So the h
Yes. Technically, it is a. Yes. Very good. Because that's the theory. Remember, the theory was we're trying to move h, which is how far away from 2, from that point 2. We just want it to be slightly away. So it's technically not 0. It's not an extra unit away.
Treat it as something else.
Yeah. We treat it so small, very close to 0, but it is not 0. Yes. But we know that when we sub it in, how do you sub a very small number? We can't. So it's easier if we just remove it by removing the denominator. Okay, so that's why you need to expand 2 plus h cubed. Just out of interest, anyone know how to expand 2 plus h cubed? Yes, Seb?
8 plus 12h, I think.
Yep, so 2 cubed plus
3, 2 squared h.
2 squared h, good.
Plus 3, 2x squared.
Good.
Plus h cubed.
Very good. For those who forgot the rule, I'm just going to write it down here on how Seb would have got this step here. The answer, or like, how do you expand cubic brackets if you forgot? A plus b cubed is the same thing as writing a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so copy that rule down if you've forgotten it from cubics. That was in term 2 or term 1 that we did. Okay, yep, it was this year. So that's how you expand, and that's what Seb was doing there. He was doing a cubed, which is 2 cubed, and then 3 times 2 squared times h. That's essentially what he was doing. Okay, so if I write it down here, if I simplify it, 2 cubed, which is 8, plus 3 times 2 squared, which is 4h, plus 3 times 2, which is 6h squared. Is it?
12h.
Oh, sorry. Yeah. 12. 12h plus 6h squared and plus h cubed minus 8 divided by h. And the 8s will cancel out.
But then you also can see that the h's cancel out as well. That's why your final answer was 12 plus 6h plus h squared. But notice in my notation I'm missing the theory. The theory, we said that h is a very small number. Okay, and I haven't wrote that down. How do you write that again? I wrote it at the start before. I wrote limit.
Oh, so this is just 12.
Yep, so for all of these, you're meant to have limit h approach 0, limit h approach 0, limit h approach 0. So if it approaches 0, you can roughly say 6 times 0, because that's a very small number, and 0 squared is a very small number. Technically, they're all zeros. Your gradient at 2, 8, or when at x equals 2, because that's what the question is asking, find the gradient of the tangent line at x equals 2, is that 12. Okay, because now I've replaced the x equal to 2. Okay, so that's the theory. Now next lesson, I'm going to make more videos of this first principle so that you understand the theory. But next lesson, I'm going to just show you a rule, because the rule will shortcut all this. The rule avoids you doing this over and over. That's why you learn the rules. There's power rule, chain rule, product rule, and quotient rule. They're just trying to avoid you doing this. This takes too long to do. But you still need to know how to do this. Okay, so that's why first principle is important. And you're going to learn rules. You're going to learn different rules too for different situations. Because different situations require different rules, and there will be a point where you can't use any of the rules. Then you have to go back to the basics.
I won't remember. So wait, does that mean that the gradient is always 12?
No, at 2. Because I replaced the x. See, remember the original x? What was my original x? It was 2.
Oh, yeah.
Whereas in my previous example, which...
So only when it's 2.
Yeah.
So is there a relationship?
Is there a relationship?
So you know how like last time in a problem?
Yeah, we got to get a rule next lesson.
So how did you get from 2 to 12? Textbook? Is that just like times by 6?
I'll quickly show you. You can figure out the rule for it. Now, we had before when y equals x squared, right? We ended up with the derivative is, the gradient was 2x. And then now when we have an x cubed, we ended up with, oh, well, you didn't know the answer. When x was, what did we use before? X equals 1, then this ended up being 2. Now we've got something equals to 12 when x is 2. I don't know if you can pick it up. But anyways, I'll show the first rule. It's 2x for the first one, and the second one is 3x squared. There is a pattern. That's called the power rule. But anyways, I'm going to stop the video.
So if x